is a pleasure for me to present on behalf of our geopark, Laia. Otherwise, she would have been to present herself. So Laia is one of our main collaborators, scientific collaborators from the University of Zaragoza. And together with the University of the Basque Country, they have been working for a long time in this section in Zumaia. So it's a great pleasure for me to introduce her, explaining our Zumaia section among the first 100. Laia.
Okay, so I'll control the time myself. Thank you, Asier. So I'm coming on behalf of the International Subcommission on Paleogene Stratigraphy, and for me it's an honor to present Zumaia, the Zumaia section, also on behalf of my co-proponents, Asier Hilario and Victoriano Pujalte. And Zumaia is one of the best exposed, most continuous and highly studied outcrops of deep marine sediments in the world. And well, I'm very glad that we are going on a boat trip this afternoon so that you can see the outcrops. So the location of Zumaia, I'm assuming you all know where Zumaia is, as you made it here, and you are sitting in this session today, so it's quite obvious. We are in the north of Spain, in the Basque Country. We are very close to the border with France, and about 56 kilometers east from Bilbao. And from the geological point of view, during the early Paleogene, the Pyrenean domain was an east-west elongated marine gulf here, and this gulf was opening to the Bay of Biscay. So the Basque Basin was the deepest part of the basin, and it was surrounded by a broad carbonate platform and by alluvial plains. There was a siliciclastic input from the Massif Central and from the Ebro Basin, and also there was a source of carbonate material from the east, from Catalonia. And sediments exposed along the coast from Zumaia to the two villages west, Zumaia, Deba, and Mutriku. These sediments consist of about 5 kilometers of flysch deposits. This is quite remarkable indeed. And these flysch deposits are well stratified deep water deposits, usually lower bathyal, deposited at about 1,000 meters depth, and they are very rich in fossils. And they provide an almost continuous sedimentation for more than 50 million years, from the lower Cretaceous, the Albian, to the lower Eocene. And also, lithologic cyclicity is largely controlled by orbital forcing. And you will see it very clearly when we look at the outcrops from the boat this afternoon. So sediments along the coast in Zumaia contain 4 main units that we'll see this afternoon. And I'm going to describe these 4 units that go from the Maastrichtian, the Upper Cretaceous, to the Lower Eocene. These sediments mostly contain rhythmic alternations of limestones and malstones with some intercalated, thin-bedded intercalated calcareous, siliciclastic, and mixed turbidites. So these are the 4 units that range from the Upper Cretaceous, from the Maastrichtian. This is the Zumaia Algorri Formation. And then in the Paleocene, there is the Aithgorri limestone and the Itzurum Formation. And finally, in the Eocene, there's the Heiskibel Formation. And remarkably, these sediments contain some of the most important events of the Paleogene, and they include the Cretaceous Paleogene impact event. They also include the most remarkable global warming event of the last 90 million years. That's the Paleogene-Eocene thermal maximum. We can also see some minor hypothermal events, and also we have two GSSPs for the basis of the Selandian and the Thanetian stages of the Paleocene. So I'm going to describe some of these events and GSSPs in detail. To start with, from the modern to older, I'll start with the PETM. The Paleocene-Eocene thermal maximum is the largest hyperthermal. For those of you who are not familiar with the word hyperthermal, they are global perturbations of the carbon cycle associated with negative excursions in carbon isotopes, and also with, of course, negative excursions in oxygen isotopes, and very often associated with dissolution, carbonate dissolution at the seafloor. So here we can see the outcrop of the PETM in Zumaia, and this is the upper Paleocene limestone, and the lower Eocene is represented by a red siliciclastic unit. At Zumaia, we can clearly see the negative excursion in carbon isotopes that marks the onset of the PETM, and also a decrease in the calcium carbonate content associated with dissolution, but also with dilution by siliciclastic material. During the Paleocene-Eocene thermal maximum, we see the largest extinction of deep-sea benthic foraminifera during the last 90 million years. And this is a figure showing the extinction of 55% of the species of deep-sea benthic foraminifera. Moving down to older materials, we have two GSSPs that mark the basis of the Selandian and the Thanetian stages. So this is the Selandian-Thanetian transition, and the GSSP was located at the base of Cron C26N. If you have a chance to go down the beach, you can see this outcrop, and you will be able to see the golden spike and a plaque. So 2 meters below this boundary between the Thanetian and the Selandian, there is another very interesting event. It's a minor hyperthermal event, this one marked in blue. This is the mid-Paleocene biotic event. And it's also very interesting because it has the same characteristics of the PETM, but of a smaller magnitude. Okay, so for example, you see that this is the mid-Paleocene biotic event, and there is a negative excursion in the carbon isotopes, and also a decrease in the calcium carbonate content. Also, we have documented the biotic response of plantic and benthic foraminifera and calcareous nanofossils. So the study of these minor hypothermals can be used as analogs for the current climate change. The second GSSP here in Zumaia marks the base of the Selandian stage, and is located at the base of the Itzurun formation, and it also has the golden spike and a plaque that you can easily see from the beach. And finally, at Zumaia, we can see the Cretaceous Paleogene boundary. You can only access the outcrop at low tide, so be careful with that. And right at the Cretaceous-Paleogene boundary, we can see a very thin millimetric layer that concentrates all the impact evidence. There is the iridium anomaly, microtectites, and at this level, we can also recognize the extinction of many groups, including ammonites, plantic foraminifera, calcareous nanofossils, and so on. So the scientific tradition of Zumaia, there is a long scientific tradition of geological studies in this region, starting probably with Ramón Adán de Yarza in 1884, who highlighted the importance of the Cretaceous rocks in Zumaia. But also, there have been many, many theses dedicated totally or partially to these outcrops. The thesis by Pierre Rath, Von Hildebrand, Herm, and many theses, PhD theses, in the University of the Basque Country and also in the University of Zaragoza. Same for scientific papers. There have been hundreds and hundreds of scientific papers dedicated to outcrops of Zumaia, and also photographs of Zumaia have been used for the front cover of many books, including the Petitjean Atlas on stratigraphy, sedimentary structures. And following the scientific tradition, especially these outcrops, Zumaia, is very important for the scientific, for the International Subcommission on Paleogene Stratigraphy. We've held many, many meetings here for working groups, for international and official ceremonies to define the ICS-ISPS. And finally, what are the main arguments to accept Zumaia as a geoheritage site? Well, the first one is that the deep marine sedimentary successions in Zumaia provide an almost continuous record of more than 50 million years from the lower Cretaceous to the lower Eocene. And second, that integrated magneto and cyclostratigraphic records at Zumaia have helped us to understand global events like the Cretaceous-Paleogene impact event or hyperthermals, the PETM and other minor hyperthermals. And these can be used to understand the long-term consequences of anthropogenic climate change. And of course, we've defined 2 ICS-ISPS in Zumaia for the basis of the Selandian and the Phoenician. So with this, I'd like to say thank you. I'd like to encourage you to come to the boat trips to see the outcrops from the distance. But also, if you have a little bit of time, I would invite you to go down to the beach to see the outcrops in more detail. Thank you very much.